Alright guys, today we're going to discuss chords and arcs. A chord is a segment whose endpoints are on the circle. A diameter is a specific type of chord. So yes, the diameter falls under that category. Within a circle, or in congruent circles, congruent central angles have congruent chords. Congruent chords have congruent arcs, and congruent arcs have congruent central angles. So we're given two different examples here for problems 1 and 2, and we're asked to determine what can I conclude based on the following information. So in problem number 1, it tells me that BC is congruent to DF. What else can I tell? Well, because I'm told that the arc is congruent, I see it also creates a central angle. So I can say that angle O is congruent to angle P. I can also conclude that since the arcs are congruent, the angles are congruent, their chords are congruent here. So I can say BC is congruent to DF. Likewise, I can say that BO is congruent to DP, and OC is congruent to PF. Now, we're going to use that same photo, but we're going to give some different information for problem 2, so I've got to erase. It says if you're given instead that BC is congruent to DF, what else can I say? Well, because the chords are congruent, the arcs have to be congruent. So BC is congruent to DF. We can also say that my angle is congruent. So angle O, I apologize, is congruent to angle P. I can continue saying that BO is DP. OC and PF. Oops, starting to write on my face. And I believe that's all I've got. Excuse me, theorem 12.5 tells me that within a circle or congruent circles, chords that are equidistant, okay, let's discuss this vocab word. Equidistant means same distance. I need to get this in. So if chords that are the same distance from the center are congruent, and then congruent chords are the same distance, essentially. I need to run button. So it tells me that if I have chords that are the same distance from the center, then they are congruent. And then number 2 tells me that if the chords are the same, if their chords are congruent, then they're the same distance. So it kind of goes backwards. So what's the value of A in the circle? So A is this chord length. Well, I see that chord R question mark because I see that it's not labeled. So we're going to just call this question mark over here. So chord R question mark is the length of A. Chord PR is the length of 12.5 here and 12.5 here, which would be 25. And I see that they're both 9 units from the center. So because they are equidistant, or the same value from the center, they're the same length. So since RP is 25, A is 25. Number 4, find the value of X. So I see this here chord up above is this part's 18, this half is 18, so that total 18 plus 18 is 36. I see that the second chord over here is 36 as well. So if the chords are equal or congruent, then they must be equidistant. So therefore, x has to be 16. Good. I'm just double checking we're not adding anything to our formula book yet. All right, part 2, different things going through the circle. In a circle, a diameter is perpendicular. A diameter that is perpendicular to a chord bisects, and we know the word bisects means to cut in half. In a circle, a diameter that bisects or cuts a chord in half is perpendicular. Ooh, also another vocab, perpendicular, 90 degrees. In a circle, a 90-degree chord that cuts something in half contains the center. All right, find the missing length to the nearest tenth. So I'm looking for R. Okay. I know it's a little difficult to read. I see I have this here handy dandy triangle. And I see that I have a perpendicular line or a 90-degree angle. And it tells me that if I have a chord that is 90 degrees or creates a 90-degree angle, it will cut this chord in half. It's pretty much what this guy says right here. Because I could theoretically continue to draw that diameter, it hits that chord at a 90-degree angle and cuts it in half. So that means that I can, when I get to my pen, draw this picture a little bit easier so I can see it. This is my value for R. This is a unit of 3. And instead of that whole chord being 14, I have a distance of 7. Again, we're cutting that guy in half. And then it's a right triangle, and I think, what do I know about right triangles and sides? And hey, Pythagorean theorem. 3 squared plus 7 squared equals R squared. 9 plus 49 equals R squared, which gives me 58. I see in my directions to give the length to the nearest tenth, which means I can go ahead and plug this in my calculator instead of just reducing my square root. So R is equal to 7.6. And it's in terms of centimeters, so 7.6 centimeters. Okay, we're going to use that same logic to solve problem B. I see that if I wanted to, this could be a diameter if it went all the way through. And I see that this little piece here and this little piece here are 11, which means that they were both congruent, which means that it is cut in half. So since this diameter is bisecting the chord, it then creates a right angle, which means that I can draw my picture off to the side so that I can visualize this problem a little bit easier. So I have 11 squared plus y squared is equal to 15 squared. So 121 plus y squared is 225. So y squared is equal to 104. Square root both sides. So y is equal to 10.2. And since there's no units on B, we don't have units on my answer. Okay, we are going to use the following picture to find A and B, and then this will be our last guy. So after we finish this problem, we'll talk about our formula book. Part A says find the length of the chord. So if you notice, X goes the entire distance. If it wanted just half, it would either have it marked like such, or it would just have X off to the side right under the triangle. So I see that I have a triangle. Trying to figure out the best way to do it so I can still see the picture. I guess I'll try and draw over here. It's kind of hard to get off to the bottom. Anywho, 4 at 6.8, and I have my right angle. I'm looking for that bottom leg, but I don't want to use the value of X. X is this entire distance here, and I'm only looking for half of it. So instead of using the value X, I'm going to use a little different letter. I'm going to say Z. I'm going to say that this piece here is Z, and that Z is equal to half of my distance of X, or X is equal to 2 Z's, meaning that this little piece here is Z, and this little piece here is Z. And I'm doing that so we don't confuse our letters, because then we can say if I just used X again, hey, I have X, I'm solved. That's not the case. I'm letting it be half of it. Alrighty, so we're going to use our Pythagorean theorem again. So I have 6.8, oops, that's not what I wanted to start with, sorry guys. I have 4 squared plus Z squared is equal to 6.8 squared. So I have 16 plus Z squared is equal to 46.24. Subtract it and I get 30.24. Square root both sides and I get Z is equal to 5.5. That looks like an 8. Now I found Z, but Z is only half the distance, so I need to go back and take him times 2. Oops, not Z again. Which means X is equal to 11 units. And again, there's no measurement, there's no centimeters, inches, there's no units, so he's just 11. Part B, find the distance from the midpoint of the chord to its minor arc. So I can't actually move the X, but we're going to pretend that the X disappeared. We're going to look for this distance here. Which, that kind of looks messy, so I'm going to try that again. And you're probably thinking, how on earth am I going to do this? This makes no sense. This is impossible, blah, 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 blah. Bear with me. From the center of the circle to the outside is considered a radius. And I see in this example my radius is 6.8. And I can strategically draw this radius anywhere, so long as it hits the center and goes to the outside. So that total distance is a distance of 6.8. Now if I clean up my circle a second, I can see that I already have 4 units. So I just need that little piece in between. So I'm going to go ahead and subtract. So that distance is a distance of 2.8. All right, go ahead and get out your formula books. I'm going to enlarge in my photos so you can see what we need to write. Okay, so remember we're doing definitions and words on top, problems on the bottom. So on the top, we want to write chord. Use a segment whose endpoints are on a circle. And we want the next 3 examples. We want one of the ones where we had to use Pythagorean theorem. I just picked this one. And then I want that last problem in its entirety. Okay. Have a wonderful day, guys.